Hello everyone, today we're doing problem 6.26, and this question asks us to classify each of these transformations as either substitution, elimination, or an addition. So let's go over what these mean. So substitution means that we're changing the identity of one atom for another. So we're not gaining any degrees of saturation, we're not losing any degrees of saturation. So if our molecule has a sigma bond, it's still going to have a sigma bond, but one of those four substituents around those central atom is going to change. So for example, we can go from hydrogen to some sort of halide, or from one halide to another halide. An elimination reaction is when we lose degrees of saturation. So from an sp3 carbon, so sigma bond, we go down to sp2 carbon, or double bond, or from a double bond we go to a triple bond. So we're losing degrees of saturation, and we're actually losing substituents while we're doing this. So obviously, to go from a sigma bond that has sp3 carbon that has 4 unique substituents, we go down to sp2 carbon that has only 3 unique substituents. So we lost a bond, essentially, that was bonded to a central atom. In addition, that's exactly opposite of elimination. So we're gaining saturation. So from a alkene, a double bond, we're going to a single bond, or from a triple bond, we're going to a double bond. And we're actually going from either an sp2 to sp3 or an sp to sp2 carbon, and we're adding on atoms to this molecule. So for example, if we had just a double bond, then we'd add on, for example, a carbon or an oxygen or something like that. So let's go over A, B, and C, and D. So we see that A, we have the central carbon attached to 2 alcohols, and we actually lose one of these alcohols and form a carbonyl group, a ketone here. So we're actually eliminating one of these alcohol functional groups, and we're losing a degree of saturation. We're going from a sigma bond to now a double bond. So this is what we call elimination reaction. In B, this carbon is bound to 2 protons, but then in the products, we converted one of those protons to a chlorine. So we didn't change any saturation, we just converted. So this is what we call substitution. We substituted hydrogen for chlorine. C, we're actually gaining molecules here. So from a double bond, we're going to a single bond. So we're adding now this hydrogen here. And so this is what we call an addition reaction. Here we see that chlorine converted for hydrogen. There's no change in the molecular structure, just the identity of these atoms. So this is what we call as well a substitution reaction.